Okay, now let's start with week 3. Okay, now just write down week 3. Okay, now let's go to your page 3.1. Okay. What we do is we're going to do projectiles, motion, and collisions. Okay. Separate up, we're going to do projectiles first. So I think the best way for me to do this is just show you some example questions for projectiles. Okay, let's start with question 1. Okay, now, okay, just let me test. Yep, that sounds good. No. Okay, again, let's read the question. A frog jumps vertically with an initial velocity, so when t equals to 0, initial means t equals to 0, velocity will be this, upwards. So we said upwards positive. Okay, now, so your initial velocity u will be positive 4 meters per second. Okay, that's u. What height does the frog reach? Okay, maximum height. When talking about the maximum height, we need to know, well, I write it down first. We have to recognize that the final velocity must be 0. Okay, now because, say if I'm throwing a ball, okay, upwards. Okay, now if I throw a ball upwards, okay, let's have a look at the forces acting on the ball. Okay. The only force that acting on the ball will be the gravity. Okay, mj, mass and acceleration. So what's happened is if the ball moves upwards, as it moves, okay, its velocity decreases, its speed decreases, because we have a gravity pulling it down. Okay. So again, when it reaches higher, it's slower. Okay. Its speed is slower. However, when it reaches its maximum point, okay, the velocity will be 0. Okay. Then it will start to move downwards. Okay. The further it moved down, the faster it is. Okay. So, when they ask for the maximum height, we have to recognize your final speed will be 0 at the maximum. V equal to 0 at the maximum height. Okay. Now we need to find x. Okay. So we have the initial, we have the final, we have x. Also we know the gravity, acceleration minus 10 meters per second square. Okay. So just for this question, gravity will be minus. Well, I use minus 10. Okay. Now, when we have all the information, go through your constant acceleration graph. Okay. Find the equation contains u, v, a, and x. Okay. Let's go to the notes. Now, constant acceleration. Now again, make sure those questions are on your those equations are on your cheat sheet. Okay. So we're looking for u, v, x, and a. So that's the one. V square equals to u square plus 2ax. So v square equals to u square plus 2ax. Then put down the value in. U will be 0. Sorry, v will be 0, u is 4, positive 4 square plus 2 times, okay, minus 10 acceleration is minus times x, then we need to find x. So I have 0, 16 minus 20x, so 16 equals to 20x. X will be 20 on 16 on 20, which is 4 on 5. Yeah, 4 on 5, which is 0.8 meters. Okay, always remember the unit. So the frog jumps 0.8 meters high. Now, the trick for this is just remember gravity is always minus. Okay. Now, have a look at the next question. Let me close this. Okay, again, a frog jumps upward. Initial velocity u will be positive 4. Okay, that's initial velocity. How long does the frog take to return to the ground? So now we need to find the time. Okay. Now this time is asking how long does it to return to the ground. So well, let's write down the acceleration first. Okay, now from experience, okay, well, I know the final velocity when it returns to the ground will be minus 4 meters per second. Okay, the idea is this, we talked about it before. Okay, the only force acting on the ball will be the gravity. So as the ball moves up, okay, it slows down until its maximum point. Then it starts to drop down. Okay, so the idea is, okay, when it drops through at this height. Okay, now say position. Let me put down position A, B, C, D, E. Okay, now at position B. Okay, now if position B and position D have the same height, okay, when it drops down, they should have the same speed, but in opposite direction. Okay, so similarly, if the frogs start jumps at 4 meters per second, when it lands, okay, it should have the same speed but different direction. Okay, so we have a minus 4 meters per second. Okay, now after this, we have u, v, t, and a. We go to your constant acceleration formulas. Find the equation with u, v, t, and a. U, v, a, t. Yep, that's one. So v equals to u plus at. Okay, final velocity will be minus 4. U will be 4. Acceleration again minus 10. Don't ever forget the minus sign because going up is positive. Okay, now and t. Solve the equation. Minus 8 equals to minus 10 t. T will be 8 on 10, which is 0.8 second. Okay, don't ever forget the unit. Okay, now let's go to the next question. Okay, someone is riding his bike on a level road. Okay, at a speed of this. Okay, so that's the speed. The tail light breaks off. Okay, now the tail light breaks down, it takes this much time to reach the ground, so that's my t. Okay. Well, I don't label this because I have no idea what kind of speed is that. Is it initial or is constant? I have no idea. So I leave this, but time I label it t equal to this. How far above the ground was the tail light when it was attached? Okay, so I have something here. Okay, so a tail light is here. It's initially moving forward at 5 meters per second. Okay, then it drops down. Okay, so when it drops, it takes. Okay, then when it drops down, it takes 0.45 seconds to reach the ground. So when it's dropping down, so well, let me draw it this way. Okay, after a while, the tail light will be here, dropped down, but it is still moving forward 5 meters per second. Why? Okay, now because if we look at the tail light, okay, the only force acting on it will be the gravity. Okay, when it breaks off, okay, the only force acting on it will be the gravity. Force of gravity. Okay, it's still moving forward, but there's no. Well, I assume the question means a constant speed. Okay, the speed, horizontal speed doesn't change. It's moving forward. So after a while, it's still moving forward, but it's lowered. Then after a while, it's still moving forward at the same speed, okay, but dropped down. Then afterwards, well, until it reaches the ground. Okay, sorry. Until this thing, until the tail light is on the ground. Okay. Now, what's happened is it asks how far above the ground, the height. Okay. When it was attached. So all we interested here is the vertical motion. Okay. We don't want to know anything about the horizontal motion. We understand like this, the question asks only about the vertical motion. So what we do is, just give me a second. Okay, now it breaks off. Okay, so the initial speed for it moving down, just remember we only consider the vertical motion. Okay, now that's your x component, that's my y component. We only consider the y component. Okay, so let me do this. Okay, we only care about the vertical, okay, because we need to find this vertical x. Okay, so my initial speed must be 0. Okay, because it's just break off, it's stationary here, then it's moving down. Acceleration will be -10, the gravity. Okay, then the time is 0.45 second. I need to find the x. Okay, go back to your constant acceleration equation, find the equation with u, a, t, and x. So that's, by the way, okay, I'm not very good at memorizing things. Okay, so I have to refer to it all the time. U, A, T, X. So now this one, yep, this one seems fun. Sorry, this equation seems fun. We have this U, A, X, T. So let's write it down. Okay. Okay. Now substitute all the value in. Okay. 0 times plus half times minus 10 times t squared. That's a 0. Okay, 0 just cancels out, will be a 0 minus 5t squared. Sorry, I need to substitute t in. Now 0.45 square. Use your calculator, you should have a number. Okay, I'm not going to do it. Well, let's do it on my calculator here. Okay. Well, let's just do it in your calculator. I forgot the number. It's minus a number, minus something. Okay, meters. Okay. So when you find this answer, okay, forget about the minus sign. Okay, the minus sign is the displacement. It's how far it moved down. Okay. Because it moved down, it's a minus. So the question asks how far above the ground. So the question, the answer should be a scalar. So your answer will be just this number. Okay, just this number. Okay, put it in your calculator, find it out. Okay, in meters. Okay, now let's go to the next question. Okay, now it's still just let me. Okay, it's the same question but with a picture. Now, his bike is riding on the road. This. Yep, we have a diagram. Okay, sketch the path of the tail light as seen by Mary and indicate the final position of the tail light. Okay, now, as I talked that before, we have a tail light here. Okay, now, as the only force acting on it will be the gravity force. Okay, so everything else is unchanged. Only the vertical position is changing. Okay, because there's no force acting on the horizontal force, which is the force here will be 5 meters per second. It's unchanged. So what's happened is, okay, now it would, okay, the tail light would just fall down in a parabola shape. Sorry guys, okay, it should be a parabola. Okay, just sorry about my, let me draw that again. Okay. It should be something like this. Yep, something like this. Okay, now it should be something like this. Okay, a parabola position graph. Okay. Why is a parabola is always a parabola? You can try to throw a ball on an angle to somewhere through something in your room now. So if you throw something, you say the path when an object travel in the air, okay, will be a parabola shape. Okay, so that's it. Okay. Yep, that's what we have to do. Okay, so basically what it means is, okay, now, well, let's go to this. Okay, now in this question, the examiner in the exam, what they're looking for is, okay, now when the tail light starts to fall, we will have a parabola shape. Okay, but when the tail light reaches the ground, okay, here it should be just when it reaches the ground, the light has to travel the same amount of distance as the person, as the back, because the speed is unchanged. The horizontal speed is unchanged. Okay, the horizontal speed is unchanged. So in the exam, they're looking for there. If you sketch a parabola, something like this, you get well, it's kind of wrong. You have to, the final point should be there. That's when it reaches the ground. Okay, now let's go on to the next question. Now, sorry, here is your two-dimensional question. Okay, a helicopter drops a rescue package to to a group of hikers. Okay. The helicopter is traveling at a speed this. Okay, well, it's labeled horizontal speed, constant height of 200 meters. Yep, you should no air resistance. Okay. What is the speed with the package? Okay, the speed, we're looking for speed, not velocity. Package when it hits the ground. Okay. So similarly, the package drops, it should somehow, I just draw it to show you, drop down there. Okay, it could be anywhere, I don't know yet because I haven't do the calculation. So it's looking for the speed. Now, okay, as we can say, the horizontal speed remains unchanged because there's no force acting on the package horizontally. Okay, so as the final point, we have the horizontal velocity will be 10 meters per second. However, okay, the gravity is pulling the package downwards. Okay, there must be a vertical velocity just before it reaches the ground. Okay, now what we need to do is we need to find the vertical velocity. Then afterwards, we combine these two velocity, we will find the speed. Okay, now start from here. Your initial vertical, that's for the vertical. Okay, vertical components. Okay, your initial speed, velocity vertically will be 0. Okay, final, I don't know. Displacement traveled will be minus 200. Okay, not 200, minus 200. Acceleration will be minus 10. Okay. Okay, because going up is positive. So moving down will be minus. Don't forget the minus. Okay, then looking for equation with u, v, x, and a. Go through your notes. Alright. Okay, u, v, x. Sorry, u, v, x, and t. No. Yeah, just this one here. V square. V square equals to u square plus 2ax. Now, the v square will be 0 square plus 2 times minus 10 times minus 200. Okay, your answer will be 0 plus minus 2 times minus 10 will be minus 20. Okay, minus 20 times 200 will be 4,000, positive 4,000. Okay, and the v should be square root of 4,000, which should be put it in your calculator. Okay, meters per second. Yep, put it in your calculator, you have an answer. Okay, now, so it goes downwards. Okay, also put a minus sign there because it goes downwards. Okay, that's the vertical velocity, but we're looking for the speed. Okay, so when we're doing the speed, okay, that's the vertical velocity. Okay. Now I write it down, that's the velocity. Okay, however, we need the speed. The speed will be the component of this, your trigonometry ratio, so square root of horizontal speed square plus, okay, the square root, the vertical speed square. Okay, so which is square root of 100 plus 4,000. Okay, put this in your calculator. Square root of 4,100 meters per second. Okay, now okay, yep. Sorry. Okay, the important thing here is just remember when doing two-dimensional projectiles, break the horizontal and vertical components. Okay, we will do some more examples later.